Hi, in this video I will demonstrate a deployment of the Cross-Availability Zone, CloudGuard cluster in AWS. In our lab environments I have a VPC, with an Internet gateway, two front-end subnets, prod and staging, each in a different availability zone. In each availability zone, I have a web server. The staging instance has a public IP address, the prod instance has only a private IP address. Two additional public subnets serve the Internet-facing network load balancer. The staging web server, with the public IP address, is published to the Internet directly from the Internet gateway. The prod web server with the private IP address, is published to the Internet from the network load balancer. The goal of this use case will be to protect the web servers and inspect the following traffic flows. Outbound traffic, from the web servers to the Internet. East-west traffic, between the web servers. Ingress traffic, from the Internet to the web server, and that, without changing public IP address or DNS records. For protecting those web server, I will deploy a cross-availability zone cluster, in high availability mode. Each cluster member will be deployed in a different availability zone. Each member will be connected with two network interfaces. ETH0 will be connected to a public subnet, while ETH1 will be connected to a private subnet. I will create 4 new subnets for the cluster gateways. 2 external subnets and 2 internal subnets. For the external subnet, I will create a route table. I will add a default route to the Internet gateway. Now that my subnets are ready, I will run the GeoCluster CloudFormation template. You will find the templates list on SK 111013. I will select the R8120 template for existing VPC. I will choose the 2 public external subnets that I have created, and the corresponding internal subnets. Make sure that you don't create here a cross by mistake. Each cluster member should be connected to external and internal subnets in the same availability zone. I will set a password hash. If you don't have one, you can create it from any Linux machine, with the command you see here. I will put a SIC key. And this is it, I'm ready to create the stuck. It's going to take a few minutes. Now that the stuck has been created successfully, I can move forward and create the cluster object on the checkpoint management. On the stuck output, I will find the parameters that I will need, the cluster VIP, public IP address, and the public IP address of each one of the members. I will create the cluster object with the public IP of the cluster. I will add the two cluster members with their public IP address. On the Cluster XL tab, I will select Use Geo Mode in a Cloud. Click OK and publish the changes. Now, edit the cluster object again, and select the network management. Click on Get Interfaces with Topology, and wait till if filled. I will edit Ethernet 0. The network type should be private. And I will disable the anti-spoofing. Now, I will edit Ethernet 1. I will set the network type to sync. I will disable the anti-spoofing as well. Now, I will add an alias interface to the cluster members. I will add the secondary private IP address of the external interface for each cluster member. Click OK, and publish the changes. In order to hide all the hosts that goes to the internet behind the cluster active member public IP address, I will edit the cluster again and enable NAT. For fast check that all the traffic goes successfully through the cluster, I will create an any except rule. After successful installation of the policy, it's going to take a few minutes till you will see the cluster object become green. Once it become green, you can click on the information link, and you will see which member is active and who is standby. We can see, the member A is the active member, and we will need to remember that on the next steps of creation of the routes. Now, let's start with the routes changes. I will change the default route of prod and staging route table to point on the internal interface of the active member instead of the Internet Gateway. All traffic that wants to go to the Internet from those two subnets will be routed to member A, internal interface. For inspecting east-west traffic, I will route the prod and staging subnets to the same interface. Now, let's edit the load balancer route table. For traffic that will come from the load balancer to the prod subnet, I will set a static route to point on the external interface of the cluster active member, member A. For traffic that will come to the public IP that is associated with the staging instance, I will need to create an ingress route. For that I will create a new route table. I will associate the Internet Gateway with that route table. I will create a static route. Traffic that will want to go to the staging private IP address will be routed to the external interface of the cluster active member, member A. One last thing that I forgot is to add on the prod and staging route table a static route to the load balancer subnets. So, traffic to the load balancer subnets will go through the cluster gateway, internal interface. Now we are ready to check all the traffic flows I mentioned earlier goes through the cluster. I will start by access from my browser to the public IP of the staging instance. Now, I will access from my browser to the load balancer full qualified domain name, and I should reach the prod instance. Let's verify that I see the logs of those two connections on the management. Now, I will connect over SSH to the staging machine, a connection that I should see on the logs. I will ping to Google DNS 8.8.8.8. I will access the prod private IP address. I will verify that I see the two connections on the logs. After we check that all traffic flow go truth the cluster, the last task would be to simulate a cluster failover. I will run ping from the staging machine to Google DNS, and I will shut down gateway member A, which is the active member. I want to see how fast the ping will recover. You also going to see that all the routes that currently pointing on member A will be changed automatically to point on member B interfaces, which become the active member. If you have any question, feel free to comment on the post. Thank you.